Alright, we're going to look at the eTopo1 global relief model, and it's downloadable from the NOAA website. We use this ice relief version, not the bedrock one. I've downloaded it to my account. I'm unzipping it. Now I'm going into the Atom editor where I'm going to create a Julia file to read and plot that data set. First line is the packages I use, and now I'm trying to get the file name into Julia. So there's the file name and its path. The second line, you can ignore it. Then X is going to be the longitude, Y the latitude, and Z is the depth, read from that netcdf file, the eTopo1 file. I'm going to create a variable Z0, in which I've nanned out all the positive Z values, in other words, all the land points. And that means when I do my contour plot or my heat map plot, I'm only going to plot the ocean bathymetry. And that way I could have the full color range dedicated to the ocean. So I'll plot from 0 to the bottom of the ocean at about 11,000 meters. When I make the heat map, I keep only every fifth data point. So I throw away a lot of the resolution in the data set. And that's just because my computer is too old to keep the full resolution. The fill command equals cgrad : balance. That sets the color scheme I'm going to use for the plot, and : balance is something I get from the colors package, and it's kind of a red-blue color scheme. Now, in the first line where I say heat map X, Y, and Z, I have a bug in there, and you'll see that in a little bit when I go to plot it. It's going to come out funny, right? It's all sheared out, and that's because I should have used the transpose of the Z, so I should have the latitudes running first. So that little prime is the transpose. I also add the absolute value, and I do that so that my range, my depth is positive. Finally, I get the right plot. Alright. The Earth is not a perfect sphere, it's an oblate spheroid, so the radius A that I use in my area element is the geometric mean of the polar and equatorial radii. And now I'm going to compute my little area elements. So first, I'm going to define lambda, the longitude in radians, and then phi, the latitude, also in radians. Then I compute the differential elements for longitude by taking the finite difference from two successive longitudes, then the same thing for two successive latitudes. And then I use a Julia comprehension to create an area element, a squared cos phi d phi d lambda, like I showed in the lecture. Now I'm just going to check that if I sum over all those area elements, I do indeed get the full surface area of the Earth. So I divide by 4 pi a squared, and I should get a number very close to 1. And indeed I do. And also, just for sanity check, I'm going to make sure my d phi is really equal to 2 pi over 360 times 60, and it is. And therefore I know that I really have an arc-minute data set. That was just a sanity check. Okay, now we're going to make a histogram of depths, binned by the amount of depth in every, or the amount of surface area in different depth categories. And I use that using the fit command. And I'm going to do it at a resolution of depth of 50 meters, that's the DZ. After computing, I'm going to make the plot, and that should produce a plot very similar to the one in the textbook. The only difference is that my plot here has the proper units, so that if you integrate it with respect to the depth range, you will get a number which is equal to 1, whereas the textbook one, it's not so clear that that actually works. These commands I'm putting in, these are just making the plot look pretty by setting the right tick marks and formatting the labels for the X and Y tick marks, and putting labels on the X and Y axes. And making sure that I have units on my axis labels. Alright, there's that plot, just like in a textbook. Looks nice. Now I'm going to do the cumulative sum of that histogram to get what's known as the ipsometric curve. And for that I use the Julia cumulative sum command. So it just integrates basically, and the weights obtained from that histogram. Now I'm just doing things to make the plot look pretty, setting again the tick marks and formatting the labels on the X and Y axes. A few screw ups, but eventually I get it right. And there it is.